Yeah, so we are gonna talk about gerrymandering in some more detail today. Last time was just kind of an overview of the general idea behind it. I hope you remember gerrymandering is all about drawing district lines in a way which favors one or the other of the political parties. And this is a big deal in today's politics in the US. I would like to talk about sort of two major questions, big cues for gerrymandering. First, we're going to talk about sort of how it's done, like how you can do gerrymandering, how you can look at a map and try to draw the lines in a certain way. So the first one is how to, I will say, rig elections by gerrymandering. This is an undemocratic thing to do in real life, but if you want to understand how it works, we should talk about how you actually do this. How to rig elections by gerrymandering. And then secondly, how to detect if a certain map has been rigged by gerrymandering. And the second one is maybe like the more important one in real life these days in our politics. Remember, the idea is people draw the maps in order to benefit one party or the other. But then those maps, if they are super unfair, right now the way that the systems generally work is the map has to be challenged in court, and then somebody has to convince a judge that the map has been intentionally made to be unfair. And that matter of convincing someone that the map is unfair is something that's not clear at all exactly how to measure, like how unfair really is the map. And that's what this second bit is about. How do you actually look at a map and measure specifically if it is fair or not with respect to the districts? So those are the two, major topics, questions that we're going to be talking about over the next couple weeks. By the way, we have our next test a week from today. Just a little reminder. We'll talk more about it on Wednesday. Let's address this first question. That's what I want to talk about today. How do you actually draw the lines in order to achieve certain different outcomes? So I have, like I said, this topic is very much geometric, and that means I'm going to have a lot of these handouts. So here is the first of them, just because it's going to be a pain. I can show pictures on the screen, but it'll be a pain for you to copy them down, so I'm just going to hand them out. These ones are, because of this business about the pictures, I have also, I'll hand these out at the end, I have also printed out the homework assignment that's due next week for your convenience. I posted it also so you can print it out again if you want to, but, and your friends who didn't come today, they will have to print it out themselves. So what I have here, you got a lot of them, but really I just want to talk about this one little picture. Where is it? Sorry, I just put it in my photos. You can see what kinds of pictures I have in my photo library. There it is. All right, what we have here is a very simple, I want to imagine that this is a map of a bunch of people. So each square is a voter. This is not a terribly realistic one, but I'm trying to do just a very simple example to begin with. So let's imagine that each square is a voter and they like live in this grid, all right? And the colors represent what political party they're in. So there are two parties. There's the, I'll just call them the dark and the light, right? The D's and the L's, I'll call them. These are the two political parties, and each of these squares represents one person who's in either one or the other party. And if you count them up here, I believe there are 50 squares. There's 5 across and 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's 50 total squares. So 50 voters here. And let's divide them up into 5 districts with 10 voters each, because there's 50 of them. All right, and I'm gonna divide this region up in several different ways, which is why I gave you on your sheet, I gave you so many different copies of this one diagram. So we're gonna try to divide up the diagram in many different possible ways. And sorry, I got too many papers going on here. Okay, let's say I'm going to divide it in one specific way, and then we'll talk about, I'm just doing this as an example. We'll talk about what would happen if I did it some different way in a moment. I'm going to give names to these. So that's District 1 across the top, those 10 voters. I have to make 5 districts of 10 voters each. District 2 is similar, just down a little bit. District 3, I'm going to make like this. Sorry, that's too many. That was 11 squares. I meant that. So this is number 3 here. I hope you can see what I'm drawing on the screen. Maybe I should thicken up my lines. I like my lines thick with 2 C's. Is that better? Yes. All right, so let's say that's number 3. Number 4, I'm going to put down here, all these light ones. That's number 4. And then number 5, I'm going to put over here. All right, so these are my districts. I just made those up, and of course there are many other ways that you could have drawn the lines, but I'm just trying to talk about one particular example way that you could draw the lines. All right. And let's analyze who wins per district if you just count up the voters in each district. This is not hard to do. So in number 1, just count up. I see 4 dark ones and 6 light ones. So it's 4 darks and 6 lights. So the lights wins in District 1. All right? You imagine these people are each voting on a representative. Okay. Number 2 is exactly the same. Again, if you count up the squares in District 2, we see 4 dark ones and 6 light ones. So in number 2, it is also 4 dark and 6 light. So L wins. L wins number 1. L wins number 2 also. Right? And I'm just going to say for each of the other ones, number 3, who's going to win in number 3? The L's also, yeah, if you count those up, I see 2 darks and 8. So number 3 is 2 darks, 8 lights. So L wins number 3. In number 4, I see all whites. So there's 0 darks, 10 light. So L wins number 4. And number 5, it's all dark, right? So this is 5 dark, not 5, 10. 10 dark, 0 light. So the darks win number 5. I got a handout. Sorry to make you walk
Thank
on
you.
that.
No, that's fine.
All right, these are the results for these particular districts, okay? So can we say overall, in terms of out of these 5, what's the total kind of victory here? So of the 5 districts, L wins, according to my division there, L wins 4 of them, and the dark wins only 1. All right. This is my analysis of that particular division of the regions into 5 categories. All right. All right. Now, that's just this particular way that I decided to divide up the regions, and of course there are many other ways that you could do it. I want to talk about, big questions that I have for examples like this. I would like to know, generally speaking, I would say, like with other choices for the districts, like drawing the line slightly differently. Which overall outcomes are actually possible? Right, like the outcome that I just drew, the one that I drew, has that outcome that you see right now. The lights won 4 districts and the darks won only 1 district. Is it possible, what I would like to know, is it possible to draw the lines differently so that the L win 3 and the D's win 2? You might think, yeah, maybe you could do that. Could you make the L win 2 and the D's win 3? Could you make the L win all of them? Could you make the D's win all of them? These are the kinds of questions that I want to ask. That's what I mean by which overall outcomes are possible. And then another question would be, now once you know which ones are possible, can we actually draw them? And these are actually 2 different questions. They sound kind of the same, but which overall outcomes are possible? And then also, can we actually draw each possible outcome? All right. These are questions to be asked, and this is what we're going to be talking about for the most part today, and maybe some tomorrow also. Which overall outcomes are possible? I'm going to get another copy of that picture so that we can talk about it some more. I've got to go looking for it again. Sorry, I tried to arrange my pictures so that it appears first, but I guess it didn't work. All right. In the previous example, we had 4 districts going for the lights and only 1 going for the darks, right? Is it possible to draw the lines differently to get a different kind of outcome? As far as which are possible, what outcomes are possible? We can figure this out kind of by looking at the numbers. In this case, what we have is 5 districts of 10 people each, right? And of those people, we can just count up the boxes and see how many of those people are actually the dark ones versus the light ones. We have, there's 10 rows here, so this is 20 dark and then 30 lights if you were to count them all up. So we have 20 D voters, 30 L voters. All right. And so I would like to know how many is it, even like, don't even think about the shapes, but just like in theory, is it possible, for instance, for the D's to win all of them? Can the D's win all 5 districts? I think there's just straight up not enough of them in order for them to win all 5 districts. So we should also think about the threshold to win in each district. This is sort of the key idea that you want to focus on when I'm asking you which outcomes are possible. There's a certain threshold to win in each district. Each district has 10 voters in it. So how many do you need to win a district? You don't actually need all 10 to be on your team to win in a district. I think you should say 5 or 6. I would say 5 is a tie, which is not good enough to win. I want to talk about straight up winning. So yeah, you need 6 in order to win each district. The threshold to win in each district is 6. That's because there's 10 in each and we need 6 to win. A tie doesn't count. All right, so there's 10 in each district, so we need 6 to win. So how many total districts could the D's win in theory? So I would say the D's, they could win 3, because this would require, if you need 6 to win any district, right, then it is impossible, in theory, possible for the D's to win 3. This would require 3 times 6, which is 18. And there really are, there are 20 D's. So it is possible for the D's to win 3 of them, because they can make that threshold 3 times, all right? But I don't think they could win 4. So the D's could win 3, but the D's cannot, no matter, I'm not even talking about figuring out where the lines go. No matter how you make the lines, the D's can't win 4. That's because winning 4 requires 4 times 6 would be 24 D voters, but there's only 20. So that's going to be impossible no matter where you put the lines. All right? The D's could win 3 districts, but they cannot win 4. All right? So this is a partial answer, I guess, to my general question up there. Which overall outcomes are possible? In this example, it is not possible for the D's to win more than 3. So that means my conclusion would be the D's could win 0, 1, 2, or 3. But they can't win any more than that, right? Because of what I just said. And we should also think about the L's for the same reasons. Can we try the same kind of analysis for the L's? Is it possible for the L's to win various amounts? The L's. Could they win 3? Well, winning 3 requires 18, and what I set up here, there are 30 L voters, so they definitely can win 3. Could they win 4? 4 would require 24, and they have 30, so they can win 4. Could they win 5 districts? That would be all of them. Actually, I think they could, right? In order to win all 5, the L's, they could win, I would say, they could win all 5. That's because this would require 6 times 5, which is 30, and they have 30, right? And there are actually 30 L voters. Okay? So the D's could win 0, 1, 2, or 3. The L's actually could win any amount. They could win even all of them, is possible in theory. Now we need to talk about how would you actually draw the lines to make this happen, but that's a separate question. All right? So I would say just to summarize what I've said so far, so the possible overall outcomes are, we could have the D's, like I said before, the D's could win 0 and the L's could win 5. So I would say the possible outcomes are D0 and L5, right? We could also have the D's win 1, which means the L's have to win 4. Of course, there are 5 districts, so if I say how many the D's win, then the L's automatically win all the other ones. We could have the D's win 2 and the L's win 3. We could have the D's win 3 and the L's win 2. And that's it. It is not possible for the D's to win any more than 3, which means these are the only possible outcomes. So maybe you could imagine, what about D4 and L1? But that's not possible because of what we said earlier. D can't win more than 3. And similarly, there's another, at least if you don't know anything, you might think this was possible, but again, it's not possible because we already said D can't get more than 3. All right? So we have only really 4 possibilities as far as what the overall outcomes could be in terms of drawing these arrangements. I would like to try to actually draw pictures for those first 4 different arrangements. So let's try to draw these let's try to draw these. And actually, the one that I did at the very beginning, do we remember? This one here was, the overall result there was the L's got 4 and the D's got 1. So I'm going to say that's this one, right? This we already did. All right, so let's try to draw the other 3 possible results here. How about, well, we did the 1D and the 4 L's. How about the, let's try 2 and 3. Let's try D getting 2 and L getting 3. I would like to try to demonstrate some basic strategies here, because this is the kind of thing that I'm going to ask you to do on your homeworks. Just get another one of these pictures. Anybody use, I'm using Notability. I really don't like how you can add a picture like this, but now to get rid of that box over there, I'm tapping on the other side, but that doesn't do anything. You have to tap cancel, even though I don't want to cancel what I just did. This annoys me. Cancel.
I use GoodNotes.
You don't have that problem? Yeah.
So
Yeah. This little disaster that I just lived through, I could avoid by using a different app. But the university pays for me to get like the fancy version of Notability, so I'm locked in now. Although there may be good notes. Yeah. Yeah. Look how many colors I get to choose from, huh? That's a pro user right there. Look at that.
Thank you, Fairfield.
Yeah, your stag money at work. All right, so let's try and draw this 2 darks and 3 lights. There are some general purpose strategies that you can use in order to make this happen. When I look at this, I would say I might find myself having a hard time making it to 2 darks, because the dark ones are kind of the minority in this example, right? There are more light voters. So I'm going to say here there are less, or I should say fewer D voters. So I'm going to pick 2 districts that are intentionally full of D voters, just to make sure they can really get 2, right? And then hopefully the L's will just win all the other ones. So I need to make sure the D's get 2. I think the easiest way for me to do that would be, maybe I'll just pick one that's just full of D's. How about like that, right? So this is number 1. This definitely is going to be won by the D voters. And then can you see how to choose another one that the D's will win? I think you can just pick those other ones down there. So when I choose it in this way, I'm guaranteeing that the D's are going to win those 2 districts. And then I want 3 L's, and I just divide up the rest of them into 3 groups, however you like. So maybe I could go, now you do have to have 10 voters per region. So I'm going to divide up those white ones into groups of 10, and they can be sort of weird shapes if you want. How about like that? Here's one. I'll call this district number 3. I have to put 10 in each, so maybe I'll do one. This will be cute. How about like that? This is number 4, and then this at the bottom, this is number 5. All right. These are my districts. So to get 2 darks and 3 lights, I just, to me, like, since there are fewer darks in the picture, I was fixated on this first, and I just forced it to have 2 that are all dark, and then the rest are all white. Now, ordinarily, you're not going to have all darks and all whites in each of these districts. But anyway, I will say D wins 2, and L wins 3. That's what's important about my division into these shapes. All right, that was 2 and 3. This one was, in my opinion, not so hard to accomplish that division. All right, let's try another one. How about, okay, so I'm just trying to go down the list. I just did 2 and 3. 1 and 4 was done before. Let's try 0 and 5, D0 and L5. So this one is going to be a little trickier. You have to think a little bit more about how exactly am I going to make it so that the D's win 0. This is kind of in my opinion, this would be a very lopsided result, right? Because there are quite a lot of D voters there. You have to make it so that they don't actually win any of the districts. And there's a strategy for this. The strategy is called the strategy to ensure that the D's lose every time, because this is what we're trying to achieve in this particular division. We want to make it so that the D's lose every time. The strategy to ensure the D's lose every time is called cracking. The idea is I see all the D's over there on the left side. I want to draw the regions to crack them up so that they are not all together in the same region. So that is to say the D voters must all be split up to make sure they don't win any. You have to make it so that they never have 6 in the same region. And actually we also don't want any ties. So really we want to split them up with no more than 4 in any region. This will ensure that they can't win any of them, right? If we split them all up so that there's no more than 4 in any region, that will be a guarantee that the D's cannot win any of these regions. And actually there's kind of a cute way to make that happen. Can anybody see by looking at the picture? How could I split them up so that there's no more than 4 in any one region? Yeah? Yeah. If I just kind of draw horizontal regions like this, right? This is a region in which the D's have only 4, but the L's get 1. So that's a L region in terms of who has a majority in that one. And then if you just do that all the way down the whole picture, this makes L's win every time, right? If you did this in real life, I would regard this as super unfair to the D's. You intentionally cracked them up so that they never have enough in any single district to actually win any of these elections. All right? So here the D's are fully cracked. That's what they call it. We cracked them. We cracked them good. We made it so that they were evenly dispersed, which means they were never allowed to, they were never able to actually win in any of those 1 elections. In any of those 5 elections. All right, great. Let's just try the last one that I wanted to do. This one here, D3 and L2. Let's try that one. That guy, oh, I should checked off that one. All right, the D3 and the L2. And this one, I have another cutely named strategy for this one. D3 and the L2. All right, let's see if we can do D getting 3, L getting 2. All right, this one is maybe the hardest one to figure out how to do because the D's, in my opinion, this is again a very unbalanced result. I would say an unfair result if this actually happened in real life because, of course, there are more L's on the picture. There are more L voters. How could it be that the D's win more districts than the L do? Actually, it is possible for that to happen with some clever gerrymandering. So in this case, there are more L voters, and we want to prevent them from winning too much, right? We want to prevent the L's from winning very many. And there is another strategy for that, And this is referred to as packing. And these two words kind of go together when you read about gerrymandering. It's all about packing and cracking. Packing is what I'm going to do in this case. We'll pack the L's into two sort of, I will say, pure L districts. What I mean by that is, I'm just going to draw two districts from the get-go, which are all L. So maybe something like here's one, and here's one. These are two shapes that I used earlier in one of the other examples. All right. So that's a L, that's a L. All right. That's called packing. And then I'm going to draw the remaining districts so that the L's can't win any of them. And hopefully, you know what, I'm just looking at my picture at the moment. Can I change my mind? Sorry, I know this is a pain. Yeah, the geometry doesn't quite work out. You will see when you're doing this on the homework, this sometimes requires a little bit of trial and error. I'm going to put it down here. You'll see why in a moment. All right. Pack the L's into two pure L districts, and then you should be able to draw regions for what remains so that the D's can win in the other ones. All right, so make the D's win the others. And remember, winning requires, it needs, in order to win one of these districts, we need 6 D's in each of the others, right? So I'm going to try to draw the other districts by grabbing 6 of the D's and maybe 7 sometimes. And, you know, I still am not sure about my lines. I hate to change it again. I think I want to, though. Sorry about this. My lines, I think to make this work, I should do something like those 6, and then, no, that's what I did before. I want to take these guys for like that. You got to make sure there's 10 every time. I should have practiced it. Oh, I should have practiced this before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, all right. Okay, what I'm going to try to do now is make the D's win all the other ones. This is why I gave you so many different copies of the picture. You'll see when you're doing this that it is easy to decide that you mess it up and try again. So I'm going to make D's win the others. I need 6 D's in each. So my strategy is take these 6 D's here and then give them 4 L's to go with. So maybe these 6, and then they get those 4 L's. All right, that's a D victory right there. All right, and then do this 2 more times. Let's take the next 6 D's here and put them together with 4 L's like there. That's another D victory. And then what is left over is all these. That's 8 D's and 2 L's. That's another D. All right. And so the D's have won 3 and the L's only 2. This is made possible because we packed the L's into 2 pure L districts like this. It makes it so that the margins can go in D's favor in the other ones rather than these ones right here. All right. This is called packing. So these 2 basic strategies are packing and cracking. Sometimes you want to push a lot of people together, which means there will be less of them to win in the other districts. Or sometimes you want to split people apart so that they can't win very much of anything. All right. I have another example. We got 15 minutes left, which I think is enough time to try. I would like for you all to try in here. This is just another bunch of squares. It looks similar. Next time we'll do some more like realistic looking maps. I just wanted to do simple ones today. All right, so what we have here is 8 by 8 square. A 8 by 8. Where is it? Here. You might want to turn your paper so that it matches the orientation. I know it's hard to tell which way is up here. If you want it to match my picture on the screen, there's a right way and a wrong way to hold it. Anyway, here we have 64 voters. And if you count them all up, which I did, there's an even split. So there's 32 and 32. 32 dark, 32 light. I would like to try to make 4 districts of 16 each. And I'm going to let you guys try this one. Try to make districts with the results 3 dark and 1 light. That means divide this into 4 regions so that the darks win 3 and the lights win 1. Try 2 and 2. And try 1 and 3. All right. I would say in this example, there already is an even amount of voters. So probably if you just divide it more or less at random, you'll probably get 2 and 2. That's, in my opinion, that's like the natural result. These other ones are more extreme, and you'll have to try a little bit harder to get one of these other 2. I will give you a little hint for this one. I would say something like pack 1L and then let D win the rest. That's my pro tip for that one. See if you can pack together a whole lot of L's into one of them, and then that more or less automatically means the D's will win the other 3. All right, I'll give you a few moments, see what you think. I'll walk around and see how you're feeling. You are dividing this into 4 districts of 16 each.
Yeah, yeah. I already have it, yeah.
Yeah, you packed it. Great. How's it going? All right. Need 16 in each region. All the way across the bottom of that. All right. Can I make a suggestion?
Yeah.
Yeah, you should. I didn't like it. I don't, is all L. And then if you just divide the others out, then you know that it's probably the D's will win. Is that okay? Yeah, that's great. All right.
I'm at a loss.
Which one are you trying to do? 3 D's and 1 L? So my strategy, I found my suggestion. My suggestion was pack one with all L's, and then that would mean that the D's will naturally be L's. I'm going to start drawing my pictures just because we need to go in a few minutes. Maybe we can just talk about them. So my first one, to get 3 D's and 1 L, let's say that's what I'm going to do here. Following my own advice here, pack 1 with L's and let D's win the rest. So what that means is I'm going to try to draw one district which is basically all L's, and they are allowed to win that one. And I mean, there are many different ways that you could do this correctly, but what I see is like a fairly big kind of block of L's over here. So I'm going to try to make that into one district. And each district, remember, has to have 16 in it. So if I take, let's say, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I think if I do like this, I'm trying to get basically all L's. And I just chose a region of L's that happen to be all together for convenience, right? And I think, just to make sure, I need 16 in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think that's 16, all right? You didn't have to do it exactly like that. There are several sort of nearby variations of that, which I saw when I was walking around. So that district is definitely gonna be L. We'll win that one. And now I should be able to just divide the rest. If you think about it, I just used up like most of the L's right here. And so if you just divide the rest into 3 equal parts, then probably the D's will win all of them because there aren't a lot of L's left over. This is the beauty of the packing strategy. When you pack one full of L's, there just aren't enough L's left to win any of the other ones unless they get lucky somehow. So I'm gonna take these 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That would be 16 right there. And here I have only 6 lights, which means there must be 10 darks because I'm making regions of 16. So this will be a dark win also. And then this one up here, that's 9, 10, 11, 12, 13, 14, 15. Let's take that one also. So I put 16 like that. This one also, the darks will win. I see only 1, 2, 3, 4, 5, 6 lights in here, which means there must be 10 darks. There's a fair amount of like trial and error when you're doing this. You will probably find you draw a line and then you're like, nah, I gotta change it a little bit to make something work. That's why I gave you so many copies of the pictures. And then what's left over is over here. There are 4 light squares, which means there must be 12 dark squares, so the darks win that one. This is how we do it. This is the old packing and cracking. This one, I was thinking more in terms of packing. I packed one full of L's, and then the rest I just kind of divided it up, and there aren't enough L's left over to win any of the other ones. Did anybody make a division that's 2 and 2? I saw at least one as I was walking around. 2 and 2. Yeah, can you describe in words? I mean, is it weird or?
Literally just square in each one.
Yeah, so it turns, like I said, to me, 2 and 2 is sort of the natural outcome in this example because there are equal amounts. And it is natural to just try dividing it up like this. And if you do divide it up like that, you will naturally get, so I believe the L wins this one, and the D wins this one and this one. Is that what you said when you count them up? Yeah, so the 2 by 2 or the 2 and 2 is the most natural outcome in this example. Okay, and then the last one, this will be 1 D and 3 L's. For this one, it's another, I would think of this in terms of packing again, although it's packing the other way around. So I'm going to pack one full of D's, and then make it so that the D's can only win that one and they can't win the other one. So I would look for a big block of D's that are nearby one another, maybe up here. Now I'm not sure there's actually 16 here, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Maybe I will also pick up 14, 15, 16 like that. So there's, again, many ways you could do this. I'm going to make this kind of wormy thing. You will notice, in order to achieve these kinds of weird outcomes, you often need to use weird wormy shapes. And that's why in real life, when you look at real life gerrymandered districts, they have crazy shapes to them. It's because you need a weird shape in order to get one of these weird outcomes. So that's a D, all right? I think I'm just going to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15. That's 16, all right? And now, hopefully, if I just divide things up normally, the D's cannot win any of the others because I already used up so many of the D's, all right? If I go over here, there's a block of 8 D's. Actually, I don't want to let all 8 be together because then I'd get a tie. I'm using districts of 16, so maybe I'll cut out one of them and go 1, 2, 3, 4, 5, 6, and then 7 here, and then 3 more. So something like this. I didn't want all those 8 darks to go together because then they would get a tie, and I want to avoid that. So I have only 7 darks there, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 of the lights. So that's a L victory. Down here, again, I don't want to let 8 darks go together, so I'll pick 4, 5, 6, 7 of them, and then fill in the rest. Oh no, there's a dark, sorry, there's one more dark up here, so I'm going to go 1, 2, 3, 4, 5, 6, 7. Only 7, so that they can't win again. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lights like that. I think that does it. So this is a L, and that is also a L. All right, 1D, 3 Ls. This is how we do it.